In this video, we're going to make one more graph, and we're also going to write the equation for the graph. So let's start by reading the problem. A drill makes a well by tunneling down into the ground. I suppose that's a good thing. We wouldn't want the drill to try tunneling into the air, but another story. A certain drill can tunnel down 10 meters every 8 hours. Draw a graph to model this situation where the horizontal axis is the time and the vertical axis is the position of the drill head relative to the surface. Is the position of the drill head relative to the surface proportional to time? How do you know? All right, so we're asked two questions and we're given some information, and some of you are probably asking yourselves, what do they mean relative to the surface? Well, this drill is going down, so the surface would be point 0. 0 would be the surface, and then below 0 would be the drill moving through the ground. So I'm going to pause and set up my graph, and we'll graph these points and then look at the equation of this graph. All right, so I have set up my graph for the given situation, and let's see what I've got. I have time and in intervals of 8 hours, because I was told in the problem that this drill can tunnel 10 meters every 8 hours. And as you can see, it was said relative to the surface. So at the origin, at 0, I would be at 0, 0. I would be on the surface, and I would not be drilling down. But after 8 hours, I would be 10 meters below the surface. After 16 hours, I would be 20 meters below the surface. After 24 hours, I would be 30 meters below the surface. And what's happening here is for every 8 hours, I go 10 meters. And I'm going below the surface, so that's why I am using the negatives on the y-axis. All right, so let's connect those points. And we can see that, of course, if we don't drill, we won't be going anywhere. And I think I'm nicely lined up. Let's hope so for my sake. And assuming this drill is just going to keep on going down over time. I think I could have done a little bit better job with my line. All right, so I want to point something out to you here. We were given the time as 8 hours, intervals of 8 hours. So that was our x, and hopefully you can see this. I hope you can. And if you notice, when x is 8, let's just use these examples, 16 and 24. All right, well, what am I doing to x? In other words, what happens to this point, x, that generates this y coordinate? How do I get the negative 10 when I have x is 8? How do I know negative 10 is what y is? Well, partly from the words that were in the problem, but hopefully you can see that a pattern is emerging. And that pattern is this, that if I multiply each x point by negative 1.25, I get the y point, or the y coordinate, I should say. Pardon me. I know this is a little smashed up, but I'm going to try and do it anyway. In other words, if I take 8 and I multiply it by negative 1.25, and I take 16 and I multiply that by negative 1.25, and I continue doing that, you can see that 8 multiplied by negative 1.25, do this on your calculators, is negative 10. 16 multiplied by negative 1.25 would, of course, be negative 20. And 24 would be negative 30. And so what this means is this line is a picture of this equation, that y, the y-coordinate, is equivalent to negative 1.25 multiplied by the x-coordinate. So for any value of x, no matter what it is, if I multiply it by negative 1.25, that will tell me the y-coordinate. And that is what we're going to be doing more and more of. That's how we're going to figure out what these lines are. Anyway, just a brief preview. All right.